So as Ken mentioned, I've been asked to serve on this panel as a little bit of an outside observer to deep learning. So I know relatively little about deep learning, and I know a little bit more about human-robot interaction. So I figured I'd talk a little bit about some of the challenges that I see in applying deep learning to robotics, and let then my colleague experts actually tell you about their thoughts on of addressing these type of challenges. And I think we can't really talk about robots without really talking about people as well. And because ultimately we're building these robots and developing these algorithms to actually come in support of humans in some way. So you can think of this as this brief talk as a perspective on deep learning from the human-robot interaction perspective. So now, what happens when you take what Jitendra was talking about and all the progress being done in computer vision and in natural language processing and try to port it over to and apply it to robotics? So what you need to do is you need to give your robot training data in the form of input-output pairs that tell the robot, here's the problem, here's what you should do for that problem. And then the robot can learn from this data, and in a new situation, in a new problem, it can use the learned model to predict what it should do, right? So that's what you need to do, except as Ken alluded to, oftentimes robotics problems don't quite look like that. Oftentimes robotics problems look like this, where the robot is actually using these predictions to act upon a world, a real world governed by physics, right? And the robot is taking actions in the world in order to actually achieve a task. The world changes, and the robot gets observations based on that. And this is no longer what is called a supervised learning problem, because now your actions actually are affecting the kind of training data that you're going to see next. And also, your observations don't nicely come packaged in, here's the state, here's the action you should take. They actually come packaged in, you did this, and it kind of worked, or it didn't quite work, right? So these are the kind of observations you get. They're reward signals. They're not actual labels for what you should and should not do. So sort of the first challenge, and I'm sure Peter will talk a lot about this, in robotics alone is really that we're not talking about a supervised learning problem. We're talking about a reinforcement problem. It's really this loop that sort of changes the game and makes us kind of needing to rethink the way we do deep learning in this context. Now, where interaction comes in is that the world is actually populated by people as well, not just by objects that the robot is moving, right? And so the robot takes actions in this space and ends up affecting what people do, what people think, and so on. And ignoring this can have pretty drastic consequences. So here, this is what happens when the robot is doing stuff, thinking of the physical world and not really of the human. This is a video from one of our user studies that we did. And this is not what you want, right? So we need to embrace this as the human as part of the state that the robot is actually acting on and exploring. And so the first challenge with that, with the human in the loop side of things, is that now your actions, you have to be a bit careful about that, right? Even in just the robotics domain, because your predictions lead to actions that actually affect the world, you can be in trouble because you might break something, for instance. Now you're talking about actions having consequences on the human, and safety becomes an issue, right? You want to make sure that whatever you do and however you explore the environment to learn from it, you actually start taking into account the person. And so safety is one thing, and also the fact that the human might just hit the off button, put the robot in a closet, and never turn it on again. That's also a pretty bad outcome, right? So you want to make sure that that doesn't happen. Then there's the second part of this loop, which is the actual observations you get. And here, the human interaction kind of puts us in a bit of a pickle as well, because while it might be OK to do something and tell whether you're succeeding at the task or not, reward signals from humans are a little bit more subtle and a little bit more noisy and harder to interpret. And they might also be delayed, right? You don't want to wait until the person hits the off button to realize, there's something in here that I shouldn't have done. So that's a challenge. And then sort of the last thing I wanted to talk about was, and I'm done, I promise, is that typically deep learning has been successful due to a lot of training data, having access to a lot of training data, millions of images. And now thinking of the interaction context, you need a lot of observations, and you need observations from interaction. And so getting access to that kind of data seems like a challenge that we'll have to face. Now, not all hope is lost. I think humans pose certain challenges for these kinds of techniques, but also certain opportunities, right? So the nice thing about humans is that they're experts in the kinds of tasks that we're trying to get robots to also be experts in. So humans can actually provide guidance. And so, yeah, they're a source of challenges, but they're also a resource, perhaps. So that's also something to think about. I'm done. Thank you.